Hello, in this video, we are going to learn how a flow makes a decision. There are two ways to do it in Robomotion. The switch node, which is a list of conditions, and the function node, which is JavaScript. We will build both. The flow we build them into is a number guessing game. The robot picks a number you guess, and it tells you whether to go higher or lower. We start with an inject node, renamed to start, the way every flow does. After it, the random node from the number package. This is the number the player has to find. Its range is 1 to 10, and the round option turns the result into a whole number instead of a decimal. The result goes onto the message under the name number. Now we need a guess from whoever is running the flow, and an input box is how a flow asks for one. Its title is Guess My Number, its text is Enter a Number, and whatever gets typed comes back on the message as text. But an input box hands back a string, and a string is never equal to a number. 3 in quotes is not 3. So the toNumber node from the string package converts it. That result is our guess. Now we compare the guess against the number, and comparing is what the switch node is for. You will find it under programming. A switch starts with a single output port, and you add more with the green button under the list. Every port carries a JavaScript expression, and the robot evaluates them in order. The message leaves by each port whose expression comes out true. One click on the switch, and its ports are on the right. The first one asks whether the guess is under the number. Both values are on the message, so we compare message guess with message number. The second asks whether they are equal. That is the end of the game. And the third asks whether the guess is over the number. 3 conditions, 3 ports, and each one is an ordinary line of JavaScript. Each port now needs something to do. The first one fires when the guess is under the number, so a message box tells the player to aim higher. Its text is not a fixed string, though. The property is set to JavaScript scope, which takes a one-line expression instead of literal text. A pair of backticks and message guess dropped into the middle of the sentence, so the box says the guess back to the player. That is what JavaScript scope is for. Short string work without reaching for a function node. The middle port is the one that ends the game, so its box says well done. And after it, a stop node. The game is over, so the flow is over, and the robot goes back to being idle. The third port is the mirror of the first. The guess was over the number, so this box tells the player to come down. 2 of those 3 branches are not the end of anything. The player guessed wrong, so the flow has to go back and ask again. It needs to resume at the input box, which is in the middle of the chain. A wire all the way back there would cross everything on the canvas. So we put a label just in front of the input box and call it next number. And a GoTo after each of the 2 wrong answers, both of them pointing at that label. GoTo and Label are a jump, the same loop with none of the wire. Let us run it on a robot attached to this workspace. The input box is not something the designer draws. It is a real dialogue on the machine the robot runs on, and the flow is stopped on that node until somebody answers it. Let us answer 0. The robot rolled somewhere between 1 and 10, so 0 is under it whatever it picked, and we know exactly which port will fire. The first port. The guess was under the number, and the box reads our guess back to us, which is the JavaScript scope earning its place. Answer that, and the GoTo jumps to the label, which is in front of the input box, so the input box opens again. That is the loop. This time 11, which is over anything it could have rolled. And the third port fires instead. My number is smaller than 11. So both of the wrong answers work, and both of them loop. Now let us actually play. Halfway each time, and the range closes in until the guess is right. There it is. The middle port fired, so the box says well done, and behind it the stop node is waiting to end the run. There is one more thing on a switch worth knowing, and it is what happens when none of the conditions is true. Nothing happens is not the answer. The switch throws and the run fails. Our three conditions cover every number a guess could be, so it cannot happen here. Most switches are not that lucky. The fix is a last port whose condition is simply true. That one always matches, so there is always somewhere for the message to go. Except that now two ports match at once, and the message would leave by both of them. Which is what the stop at first match option is for. The robot reads the conditions top to bottom and stops at the first one that is true. With that ticked, the always true port at the bottom is only ever reached when everything above it is false. That is a default case. A switch is a list of conditions. The other way to make the very same decision is to write it out in a function node. So the switch comes off, and a function node goes where it was, wired to the same three branches. A function node has one output port by default. This one has 3, and that is a number you set in its properties. Double-click the node, and the JavaScript editor opens. A function is handed the message and has to hand it back. That much we know already. But this node does not have one output port. It has 3, and one returned message would not say which of them to leave by. So a function with several outputs returns an array instead, with exactly as many elements as the node has ports. The message goes in the slot for the port you want, and every other slot is null. First element, the first port. Second element, the second port. Third, the third. Which turns the whole decision into an ordinary if and else, and that is the reason to prefer a function here. You can do arithmetic on the way past. Save and close the editor. Then save the flow, because the robot runs the saved flow and not the one on your screen. Run it once more. Nothing about the game has changed. The same input box on the same desktop waiting on the same node. And the same 3 branches behind it, picked this time by which slot of the array the message came back in. Well done again. 2 ways of spelling one decision, and the flow around them never knew the difference. A switch is a list of conditions, one per port. Add a port that is always true, tick stop at first match, and you have a default. A function node makes the same decision in JavaScript and returns an array whose slot decides where the message goes. Thank you for watching.